Hi everyone, I'm Faradon. We all love new materials, right? Especially the ones like carbon capture technology that could save our Earth. But discovering a groundbreaking material involves months or even years of trials and errors in the lab. But as AI can predict the results of many experiments, does that mean scientists won't even need to step foot into the lab again? And how will that change what skills should we learn? Today, I had an exclusive conversation with Ray, and a PhD at the University of Chicago who is at the forefront of AI for material science. Let's find out. Would you like to introduce a little bit about what is this meta-organic framework and why should we care about it?
Yeah, so as we all know, meta-organic framework is a type of material, nanoporous material with two types of building blocks. We have the organic building block, which are essentially molecules, and we also have an inorganic building block, which consists of like metal centers, metal clusters. So the reason like meta-organic framework is important or useful is because we can use it for catalysis, we can use it for carbon capture, water harvesting, and there are so many applications that we can do with this kind of material, and that is why it's so exciting.
And what real-life applications can that be applied to?
Sure. So as I just mentioned, we can use it to harvest water from air in deserts. We can use it to deliver drugs in accurate positions, and we can also use it to capture carbon dioxide, those global like warming gases from the air.
Awesome. Thank you for sharing. The first question is, traditionally, how would scientists discover the new materials in this framework?
Yeah, as with any other types of materials, meta-organic frameworks were traditionally designed with a pretty long design cycle. That means when you first have an idea in mind, you try to synthesize it, you try to characterize it, and then you test its performance. If it performs good, if its performance is good, you try to optimize it, and then you do it in an iterative cycle. So that part takes a long time, and from the initial idealization to the final product, it might take months or even years. So we want to speed up the process using AI.
Oh, so traditionally, does it involve going to the lab and then do experiments?
Yes.
What experiment would they do usually?
Yeah, so it's mostly the synthesis experiment. They have the precursors, and they try to synthesize everything in a type of solution. So they want to dissolve, the node and the linker material into a solution, and then under certain conditions, they can sort of synthesize the material.
Awesome. Thank you for explaining.
Yeah, of course.
So now, with the advent of AI, how can AI replace some of the lab work?
Yeah, of course. So with AI, what you can do is you try to synthesize the material on the chip instead of in the lab. And so what that means is that you can do it in higher throughput thanks to the booming field of computation and the available resources that we have. And so instead of doing one experiment and then followed by the other sequentially, what we can do is we can do a bunch of experiments in parallel, and that will greatly speed up the whole design process. And we can also use models such as large language model or LLM to help us suggest new materials, which is it's a new field right now.
So check my understanding. Is we give AI a desired property and let it to synthesize the material structure?
Yes, exactly. So we can integrate an active learning loop with LLM. So we can let the model suggest a new type of material and predict its property and as well as uncertainty. If we choose to integrate it with batch optimization. And then based on that, we can do the manual synthesis and then come back to the model and say, this is the result that I got, and would you recommend a new recipe for this material?
That's awesome. And in your opinion, will there be a day that AI can replace all of the manual work and people won't need to go to the lab anymore? How
I'm
close are we
yeah.
to that?
I think I'm pretty optimistic about it. I think the bridge is basically robotics. If we can automate everything using AI, and also like the robotics, we can essentially greatly speed up the design cycle. And I think maybe there are some parts where it's hard to like automate, but if we can tackle that, we basically have a whole design cycle that can be 100% automated, and that would be ideal. I'm pretty optimistic about it.
Okay. So currently, even if we have AI, are there still some lab work we need to go into the lab and do?
Yes. So I think up until today, because the nature of any experiments, there are parts that cannot be automated. I mean, there are parts, of course, you can try to, for example, do high throughput testing, do high throughput synthesis, but there are parts that you cannot do 100% with those robots. So people still do it manually, and also the design of those robots might take time. So right now, I think most of the experimental work were performed by human scientists.
Awesome. And if people want to learn more about your work or blog, how can they find you?
Yeah, I've linked my contact info below, so feel free to reach out to me.
All right, thank you, Ray.
Yeah, thank you.
Yeah. So there you have it. AI isn't kicking scientists out of labs. They are giving them rocket powers to make discoveries faster. As Ray brilliantly puts it, we are not replacing scientists with AI, but making them better scientists. And that's a future I am definitely looking forward to. Thank you for watching and wish you a nice day.